This is part 2 of graphing square root functions. I'm going to do example 4 in part 2. And if I take a look at the function in example 4, what I notice is it has been shifted up 2, but it has also been reflected over the x-axis. So one of the ways that I could graph this function would be to put in values for x and get out values for y. For example, let's do a few here. I would put in 0 for x, and I would get out 2 for y. I could put in 1 for x, and that would be, the square root of 1 is 1, and then I would be making it negative. So that would be negative 1 plus 2, or 1. Let's put in 4 for x. When x is 4, the square root of x is 2, and that's negative, so I would have a point at 4, 0. And then let's put in 9. The square root of 9 is 3. Make it negative, and I get 9. And negative 1 becomes negative 3 plus 2. So if I plotted those points, 0, 2, 1, 1, 4, 0, and 9, negative 1. You'll notice that kind of looks like the square root function upside down, and that's not coincidental. Notice that I have a negative value in front of my square root symbol, which means I'm taking all of my y values here and I'm making them negative. Notice also that it doesn't go through 0, 0 like our parent function normally does. Look over here at our parent function. So what we notice is this is the square root function that's been reflected over the x-axis and shifted up 2. So let's take a look at this function from that point of view. So I'm going to erase this, and we're going to address this problem from a little bit different point of view. Let's graph the parent again. There's my parent square root function. Now I'm going to take each one of these points and I'm going to reflect it over the x-axis and then shift it up 2. So when I reflect 0 over the x-axis, that's just 0, and I shift it up 2. If I reflect 1, 1 over the x-axis, that becomes 1, negative 1, and then I shift that up 2. So right there. I'm going to take 4 and reflect it, 4, 2, and reflect it over the x-axis, and I would be at 4, negative 2. And then I'm going to shift that up 2. And last, I'm going to reflect 9, 3 over the x-axis to be at 9, negative 3. And then let's shift that up by 2, 1, 2, and that gives me a point at 9, negative 1. So what you see is you see a shift in the parent function and also a reflection. So the transformation here has been a vertical shift up 2, but also a reflection over the x-axis. My domain is all x values that are greater than or equal to 0. My range is y values that are less than or equal to 2. Notice on my graph that the largest y value I'm going to have in this reflected function is going to be 2. My y-intercept, whoops, I've got these in the wrong space. X is greater than or equal to 2. X is greater than or equal to 0. Y is less than or equal to 2. My y-intercept is at 0, 2, and my x-intercept is at 4, 0. And I can observe that by looking at the graph. Another way I could find those intercepts would be to plug in 0 for y and find what x is, or plug in 0 for x and find what y is. So let's make our generalizations here. The transformation of the parent graph from the square root of x to the square root of x plus k is a shift k units, and that's up if k is greater than 0, or down if k is less than 0. So when I shift a function, a square root function, up and down, my domain stays the same. And that is x is greater than or equal to 0. But my range shifts with k. And k is actually going to determine my range. Let's look back at these functions. In example 2, k was 3, and my range is y is greater than or equal to 3. In example 3, k was -5, and my range was y is greater than or equal to -5. In example 4, k is 2, and my range is y is less than or equal to 2. Keep in mind that I have to change the direction of the inequality because I have reflected over the x-axis. And the last thing it asks us to do is to list all the transformations that were applied in the last graph. And we've kind of already done that. There was a vertical shift up to, and there was a reflection over x. And that's it for graphing transformations.